Welcome to JD's Prep. So for the next few questions, we are going to be talking about the position of the sun. This diagram shows the sun's apparent daily path for the first day of 3 seasons at 43 degrees north latitude. So the solid lines are daytime paths. The dashed lines are the nighttime paths that can't be seen by the observer, who is right here in the middle. So our first question is asking us to draw an X to represent the solar noon position of the sun as seen by the observer on April 21st. So up here you'll see March 21st right there and June 21st right there. So April is between March and June, and it's about a third of the way in between March and June, right? It needs to be March 21st, maybe April 21st, and then May 21st in here. So we'll put an X right in this area right there. Our next question is asking us to identify the sun's apparent movement in degrees per hour along its path on December 21st. So that's the path here. So degrees per hour, so in that day that path marks out, the sun moves 360 degrees around this circle that I've just mapped out. In 24 hours, our correct answer is 15 degrees per hour. Next, we're asked to indicate the compass direction towards which the observer's shadow would point at solar noon on March 21st. This is March 21st, solar noon's right there. So then if the sun is up there, hopefully you can see that the shadow is going to be over here, pointing towards north. And lastly, we're asked to list the 3 dates shown in the diagram from the least number of nighttime hours to the greatest number of nighttime hours. So you can look at the dotted lines here to see kind of those nighttime hours, but hopefully you also have a sense of this as well, being in the northern hemisphere. The least number of nighttime hours will definitely be June 21st. The most will be December 21st. And in the middle we have March 21st. All right, thank you for using JD's Prep.